So page 717, number 81. Here's the reaction. We just read it. We've got two reaction mixtures. Okay, so what are we working on? We want to know what the partial pressure of HI will be when the second one goes to equilibrium. What numbers do they give me for the second one? It says it contains that when it starts. So they gave me a bunch of initial concentrations. So I've got H2 plus I2 going to 2HI. Initially, my H2 and my I2 are 0.621 each. My HI is 0.101. First it's asking me, is this at equilibrium? How do I know?
Because, well, in the top chart, like it's at equilibrium and H2 and I2 are different and they're both the same temperature, but in the second chart, we have H2 and I2 and the same EPM.
Okay, so almost. So the first reaction, the second reaction aren't matching up the same, but you can't just look at their concentrations. What do we need to look at to know for sure? We have to have K. And do we have K? But I know that the first reaction is at equilibrium, and I have all the numbers. So with the first reaction, I can use those numbers to find K. But you've still got to put them in. So they don't have to be equal. You could start with different amounts of everything, and then they're going to react and get to that equilibrium position.
Is this the kind of problem you have on your?
Yes. But generally they should work you to it. Like A would be like, what's K? And then they might not tell you need to do Q versus K, but then B would be, is it at equilibrium? And then you would put in Q versus K.
And the reason we can find KP over there implies that it's K for any reaction
at the same temperature. Notice that they told you the temperature for both of them. Okay, I am doing an awful job.
So they're at the same temperature.
I'm writing my equilibrium with pressures. I had to add the P's afterwards in the parentheses because they're not supposed to be the square brackets. Since these are ATMs, that means I'm calculating KP. So I'm going to put those numbers in. Remember to write your expression. You never know when they're giving you points. I was looking at the FRQ problems that we're going to work on next week, and I had a big note. This is so bad. But these problems, these rice charts take so long that my note for a hint on the AP test was skip them and come back to them if you have time, because they'll give you like 1 point when you spent like 5 minutes working on it. So as far as the whole test goes, it's a lot of work for a little bit of points. So if you definitely know that's where you can get points, then go there. If not, make yourself a note. Check this out later when I have time, because it does take a long time to do this. All right, so the first one, my HI was 0.02, and I have to square that. Don't forget to square it. Over 0.958 times 0.877. I won't have time for your quiz, so I'm going to start speeding it up. 0.02 squared. Wait, why? Oh, I'm on fix. Why is it like that? Clear that memory. 0.02 squared divided by 0.958. Yeah, right. Fix my answers, please. It's this guy, right, on the where the decimal is. I have a K of 0.000476. What does fix mean? It means all your numbers are wrong. Like, I don't know how I got on fix. Somehow it said fix down here, and then it wasn't calculating it right. Whatever I said it was over. Yeah. Yeah. Yep. Focus on this problem and then ask me. It's easy stuff. All right, so here's my K value. Does K have units? Nope, we ignore them. So now I can find Q for these. What's Q? Q is basically doing K, but I can put in any numbers, and I don't know if they're at equilibrium. These numbers, I knew they were at equilibrium. So when I was putting them in, I was finding K. Over here, I don't know if this is at equilibrium, so I have to put these in and see if the number ends up being the same. 0.101 squared divided by 0.621 squared. I'm just squaring it because they were the same. I got 0.0265 for Q. Probably shouldn't use a pencil. Just gonna wait for it to focus when it feels like it. Okay, there we go. So then Q versus K. K is smaller than Q, so this reaction is going to go which direction? Left. The only problem in the entire textbook where it switches left. So it'll be, that means that this is going that way. So yes, this is going to be being consumed, and these are going to be being made. Yes, it should be. And then, so plus x minus 2x.
So does it always go to K versus Q, or like when you write it out?
It's always K versus, I always put K first, because if I put it K first with in alphabetical order, then when I put my greater than less than sign, that shows me the arrow.
So that will work for every
All the time if you put K first. Also, so what number? Q is too big. Q wants to be K, like this is what it's wanting to get to. So this number is too big. So there's too many products, because this is products over reactants. So if I want to make this number smaller, I need to make more reactants so that Q will become smaller and become K. No. They're all gases. Then it actually, the problem says what will be the partial pressure of HI. So you're solving for this. I'll just write down what the answer is. This is a one where you have to square root both sides. Just so you know what I'm talking about, like the problem we did yesterday where it ends up being squared and then you square root both sides to solve for it. Oh, yep, yesterday was so long ago. All right, I'll keep going. So I don't have any of these numbers, so I'm going to fill them in. It's this plus this equals that. The 0.621 plus x equals that. 0.101 minus 2x equals this. Now I'm going to plug these equilibrium numbers back into my equilibrium expression, because that's the equilibrium numbers. I'm going to do that over here. Meow, 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 meow. Put it down there. K equals products 0.101 minus 2x squared over 0.621 plus x times 0.621 plus x. And this is going to equal, do I have the value for K? We do. That's why they gave us those initial numbers, was to solve it. So I'm going to set that equal to 0.000476. If I didn't have a K value, then I would go back and think, was it a vertical solve where I was, those first ones we did, where there was another clue.
So if you don't have K value for a particular reaction, you have to do that.
Generally, if you don't have the K, it's one of those vertical solve problems.
So why do you have to do that?
Do what? Set up this? This is what we always do. Because this is what it's equal to. I took the bottom and combined it so that you could see. Do you see how it's a square over a square? I don't want to FOIL that and FOIL this. Square root both sides. So that'll get rid of that. And I still have to do some distributing. I still have to do some math. Do you learn that in Algebra 2 or Algebra 1? Algebra 1? Going back to some Algebra 1 work? So you got to go back to, oh, didn't you have that in like 8th grade? 5 years ago. So the answer, the actual, oh, when you solve this, you get X. Is X the answer? X marks the spot? No, X is just the value in here to show you the change. The actual answer that this particular problem is asking me for is this box right here. So I have to take 0.101 minus 2 times X. And that answer is 0.0144 ATM. It's pressure, so you gotta put ATM after it. The question asked for the partial pressure of the HI at equilibrium, so the X isn't what it wants. I need to go back in and plug it into there. 2 times that. 2 times that. And 101 minus that. Final answer for the partial pressure of HI is 0.0145. And since that's a pressure, that would be ATMs.